Today's lesson is over section 2.1, the tangent and velocity problems. To start off with here, we want to do a little review. So as you can see on the left, we have a circle, and we have two line segments, one going kind of through two sides of the circle, MN, and one that is just touching the side, which is CB. Okay, so line AB is what to a circle O. So since it's only touching at one point, we would consider that tangent at C, and then MN is kind of going through one of the sides, so we would say that is, we would call it a chord, but we call it secant to the line to the circle 0. So now moving on to what we call the tangent line problem. We're looking at a parabola, and it has a line tangent to it at the point 1, 1. And we want to know what is the slope of y equals x squared at that point. So remember, slope is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So the difference of y's over the difference of x's. Let's call 1, 1 our x1, y1 point. And so here, we kind of want to pick points that are on the line that we currently have, or close to-ish where this would be. So let's kind of pick 2, 4, which is on x squared, to see if we can get this to figure out what the slope is. So 2, 4 gives us a slope of 3. Now, it kind of seems okay-ish, but it doesn't really look that steep. So let's pick a new point. Let's get a little closer to the point 1, 1. So let's pick 1.5, and then plugging that in gets me 2.25. And so plugging that into our slope will get us 1.25 over 0.5. And then plugging that into our calculator gives us a slope of, I believe, 2.5. And so then it looks like we're getting a little bit closer, so let's get a tiny bit closer to 1, 1. So let's say 1.1, 1.21. And then plug that in to our slope formula. Okay, that'll give us 0.21 over 0.1. And that gets us the slope of 2.1. Okay, so it looks like we're heading towards something. Now, if I actually put in the point 1, 1, hopefully you realize that 1 minus 1 on the top and 1 minus 1 on the bottom would just get us undefined. So that's why we didn't really plug in that point. So we're trying to adjust the slope of that tangent line so it gets as close as possible. So let's do something to see if we can really nail down what the slope is. So find an expression for the slope of the secant line. That's what we were doing, using 1, 1 as our first point, and then x, x squared, which is really what our second point was being represented by. We can plug that into our calculator, and let's use the table on our graphing calculator to kind of look at what the values are as we get closer and closer to that x value of 1 to see what those other x values would be. So here, if I plugged in 1, obviously that's undefined, so that's not helpful. Okay, but plugging in our other stuff, also, it looks like I have a mistake here where x squared in that y column should be x squared minus 1 over x minus 1. That's really what our y value is being represented by here. So when I plug this into my table, it looks like 1.1 is 2.1, which we already kind of talked about. But then as I go closer to it, so 1.01, 1.001, notice that all those values are getting closer and closer to 2. Going from the other side, I have 1.9, and then 1.99, and then for 0.999, I get 1.9999. So as you can see from both sides of 1, the y value or the slope is getting just ridiculously closer to 2. So because they're both approaching the same thing, we can kind of confidently say that our slope should be 2 here. So there are two problems that we said we'd talk about at the beginning: slope of the secant line, slope of the tangent line. So slope of the secant line is kind of like your average rate of change. That's why we use the slope-intercept form for that. Then also average velocity. Slope of the tangent line is more talking about instantaneous rate of change or instantaneous velocity, because we are talking about right at that exact moment. Secant line is somewhere either before that point happens or after that point happens on our functions line. So that's why it's average, kind of like just approximating. The other one's instantaneous. And so what we really want to be able to hone down is what our instantaneous rate of change is, or instantaneous velocity. And so that's kind of what we talk about for these. Okay? Have fun.